U5A2 stuff, we're looking at permutations here. So here's a great question for you. How many different ways can you make a word, and we say word in quotes because they might not be real words, from the letters, I don't know, bat, okay, B-A-T. So letters B-A-T. So I have the letters B-A-T. How many different words can I make from there? And words, again, this is considered a word in the world of math, TBA. Okay, I know it doesn't make any sense, but that's a word. So we look at this and we say, okay, how many different ways can we do this? Well, we can make a tree like before, okay? But it gets a little confusing. So let's think of it this way. If I have three different spots, first spot, second spot, third spot, and I have these letters here, and I'm asking myself, how many different words can I make up? Well, I can make this word bat. I can also do, okay, let me see, B-T-A, there's another one. I can go T-A-B, there's another one. And then I can go A-B-T, and I can go A-T-B. Okay, none of those, okay, I guess only two of those are actually words, but so there's 6 different options there, and I think that's it. Okay, again, there's no repetition. I can't go B-B-B. Okay, that's not a word. Doesn't count. I have to use each letter once and only once. And so there are 6 different options here. There's this one, these 2, and these 4. So another way to think of it is ask yourself, okay, how many different choices do I have for the first letter? And at first I can choose a B, or I can choose an A, or I can choose a T. So there's 3 different options there, right? Now if I choose a letter, once I choose one, it doesn't matter which one I choose, but let's say I choose one. So let's say I use A. Once that's gone, then I have 2 options for what's left for the second spot, B and T. Okay, and then in the last spot, so let's say I go A and then I choose T. That's gone. And the last spot I just have B, so I only have 1 option. So let's go back to yesterday's work, and talk about the counting principle. You have 3 and 2 and 1, and it's the same thing here. It's 3 times 2 times 1. Okay, so you're going to multiply. Again, it's another multiplication. So if I want to figure this out, I multiply. Okay, another way. Here's another question. Let's say there are 8 people in a race, and how many ways can they finish in a race from first to last? Well, when they start, you have 8 options for the winner. And then after that, you have 7 options for second place, 6 options for third place, and you keep going all the way down to 1. So it'll be 8 times 7 times 6 times 5 times 3, all the way down times 1. And this can be represented by this, which is 8 exclamation mark, which is not 8. Okay, not just, you don't just yell 8. It's 8 factorial. And 8 factorial means 8 times 7 times 6 times 5 times all the way down. So n factorial, you might see this, is n times 1 less than n, 2 less than n, all the way down to 1. They're all multiplying right across. Okay, so that's a huge part of this section is factorial, and that is seen here in U5A2. And you work your way through these questions here, and they're pretty much straightforward this way. There's not much difference between any of these questions here. How many 5-letter words, again, can be made by using the letters in home runs? Now this one here is a little bit different, okay, because home runs is more than 5 letters long. It's actually 8 letters long. So what you do is it's the same principle here, okay? So I have 8 options for, give me a second, 8 options for the first letter. Okay, so I have 5-letter word I'm going to make here. Okay, but there are 8 options for the first letter. Okay, so we have home run, all those different letters. Okay, so I can choose E or whatever. So I have 8 options for the first letter. So let's say I choose E, it's gone. Then I have 7 options for this letter. Let's say I choose N, it's gone. Then I have 6 options. H is gone. I'll choose that. And then the next one I'll choose O of 5. And now I'm down to 4 letters, right? It's hard to see, but M-E-R-U. Let's say, so I have 4 letters here. Now what about the end here? Like before I was going 8, 7, 6, 5, 4, 3, all the way through. But in this case, I wouldn't do that because I'm not actually picking, I'm not doing anything with the letters that I haven't chosen. So 8 times 7 times 6 times 5 times 4, whatever that is, options for a 5-letter word. 5-letter word? 5-letter word out of the 8 letters of home run. Okay, let's keep going here and look at more questions here. Okay. So again, more examples here. If there are more letters, if there were more options, etc. Okay. So this is called a permutation. So a permutation is an arrangement of objects listed in a specific order. an arrangement of R objects from a total of N objects can be written as this. So now what's going to happen is we're going to look at this a little bit differently. And this is saying I'm going to choose R objects from N objects. So there are N things, and I'm going to choose a bunch of them and order them. So for example, let's look at this right here. And it's the same sort of thing we just did, but we're going to do it a little bit differently. Okay. So here I have this question here. I have 12 books, and I want 5 of them. Okay. And I'm going to put these books. Not only am I going to choose these books, but I'm going to put them in a specific order. So first to last, I'm going to put them on a shelf. Left book, second from the left, middle, second from the right, and right. Okay. So if I was to do that like I did before, I would say there's 12 options for the first one, 11 for the second one, 10, 9, 8, and the answer is 95040. That's absolutely right. Okay, but there's another way to look at this. Okay, not the product rule, but let's do this using this rule here, which might look a little bit intimidating for you right here. So let me just write this out here. Okay, so what I have is I have 12 things, and I want to choose 5 of them. Okay, so I have 12 things, and I want to choose 5 of them. So when we have it written down in general, let me just let's start that again. If I have 12 things and I want to choose 5 of them, let me write this out in general. I'm going to take this and just cut and paste this. Let's see if I can do that. Copy image. Just save me. This is how efficient I am. And paste it, and will it work? Absolutely. Okay, great. Okay, so I was going to say lazy, but efficient is a better word. So I have N. I'm choosing this many objects of this objects, and to get that using function notation, what you do is you say, give me N factorial over N minus R factorial. So what that means is I'm going to have 12 total options, okay, but I don't want all of them. I only want to use some of them, and to get rid of the ones you're not using, you divide by N minus R. So 12 subtract 5 factorial, I'm just going to do this in full, is 12 factorial over 7 factorial. Now if you look at this and go, what's up with this? Well, let's expand this for a second. That's 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5, keep going, right? And this is 7 times 6 times 5, all the way down. So what happens here is these guys cancel each other out. 7, 6, 5, 7, 6, 5, and you're left with 12 times 11 times 10 times 9 times 8, which is exactly what you want, okay? So this is just a different way to write what we were looking at earlier, okay? So this here is a permutation. They're in order. So I have the first book, the second book, the third book, the fourth book, and the fifth book. Okay. So another thing, let's say let's go back to that race. I had 8 people, and I want to know how do they get medals in order. Who gets the gold? Who gets the bronze? Who gets the silver? How many different ways to do that? Well, one way to look at it is using counting principle and say I have 8 options for the gold. Then I have 7 options. Then I have 6 options. 8 times 7 times 6. Or I can come back and say, it's 8 factorial over 8 minus 3, 5 factorial, which is, throw that in a calculator, you get the same answer. Or you can expand that and say that's 8 times 7 times 6 times 5 all the way down. This is 5 all the way down. These cancel each other out. It's 8 times 7 times 6. Exact same thing. Okay, so a different way to look at permutations. Let's keep going here. Real quick, let's just choose a question. The local church has 8 songs. How many different programs could there be? They're going to do all 8 songs. So there's no selection here. Okay, so all 8 would just mean 8 times 7 times 6 times 5 times 4. And if you say, oh, wait a second, that's a little different than what I just did. Well, it's not. It's just we would never do it the long way because it's a waste of time. But if I said, okay, hold on, there are 8 songs and I want to choose 8 of them, what's that look like using the notation we just used earlier? That's 8 factorial over 8 subtract 8 factorial, which is 8 factorial over 0 factorial, and 0 factorial is actually 1. Okay, so it would just be 8 factorial. Okay, so 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, all right, so that's that question. If you're going to choose letters now, let's be careful here. Okay, so this one here, I'm going to have 3 letters from Quest. So now I'm choosing, there are 5 letters and I'm choosing 3 of them. But it matters in a word, okay? In a word, it's going to matter the order of the letters, right? So remember that you can't repeat any of the letters, okay? And the order of the letters matter, right? Because if I just go Q, U, and E, that's different than U, Q, and E. They're obviously different words, right? So it's 5 options, 4 options, 3 options, or again, 5p3, which is 5 factorial over 2 factorial, which is again the exact same number. Okay. So let me just pause this for a second and go back. Actually, I don't need to pause it. Where am I? Okay, keep going here. And there are more questions that are very similar to those. Let's look at this indirect reasoning part real quick, though. Indirect reasoning is used when it's easier to calculate the opposite event. So this is a really good thing here. So if I want to figure something out, sometimes it's easier to figure out the options for what's not happening and take it away from the options that are happening. So for example, if there are 4 cards in a deck that are aces, so okay, let's look at this here. It's called the complementary question here, okay, or the complement question. So some of the questions are a lot easier to figure out. Instead of saying, let's figure out what I'm looking for, let's figure out all the different options and subtract from it the things that I don't want, and then I get what I do want. So that was, I made a kind of butchered that, how I said that, but let's look at this here. Brooklyn has 6 new different colored sweaters to pile up in her drawers. How many ways can she stack them so the red sweater is not on the bottom? Okay, so instead of doing that question, why don't we figure out how many ways she can stack them? Okay, like that's a fairly difficult question. It's not that hard. We can figure it out, right? But let's figure it out this way. She has 6 different things, different sweaters. Let's figure out how many different ways she can order them. Subtract from them all the bad ones, or all the ones where the red one is at the bottom, and then figure out what's left over. Okay, so that's what we're going to do here. And so first we're going to just figure out how many different options are there to line them up, and that's just going to be 6 times 5 times 4 times 3 all the way down. Okay, so there are 6 factorial ways to line up the sweaters, and then we got to figure out how many options are there where the bottom one is the red sweater. So in this one, let's kind of figure out what we know and what we're trying to do here. If so, there are 6 factorial options just for sweaters with no order. Okay, from first to last. But then if we say, okay, the red one has to be on the bottom. Okay, so what we're going to do is figure out how many options are there where the red one's on the bottom, and then subtract that from the total number of options. Well, if the red one's on the bottom, let's say there's a red, a green, a blue, a black, a white, and an orange sweater, okay, and a red. And I want to figure out how many ways can I say this red one has to be last. Well, let's stick it last, make it last. So if it's last, now I have 5 options, 1, 2, 3, 4, 5, for these 5 spots, first through 5th. And in that case, there are 5 factorials to line those up. So 5 factorials to line that up, and then just one way to figure out what's on the bottom because I stuck it there. So there are 5 factorial ways to have the red sweater on the bottom. So figure out 6 factorial, whatever that is, and subtract 5 factorial, whatever that is, and then subtract those 2, and then you find out how many different ways are you stuck where the red one isn't on the bottom. Okay, so we're working backwards. Okay, we stick the red one on the bottom, we figure out how many options to do that, and then we subtract it from the total, and that's how many options there are where the red one is not on the bottom. It's called the complement. 11 and 12 are kind of neat, and I'll do these real quick. I'm running out of video time here. The word quip, Q-U-I-P, I'm going to make a word, but the Q and the U have to be together and in the right order. So I'm going to make words out of the word Q-U-I-P, but I'm stuck with Q and U together in that order. Okay, so the way to attack this question, I'll give you a second to think about that real quick, how to order this up. But the total number of ways you can put this together is pretty straightforward. And what you do is you think of QU as one thing, one letter kind of, okay? So Q is with U in that order, and then I can put I and P. So there's one giant letter called QU, and then I have I and P. So now you just treat it like 3 different things, QU, I, and P. So there are 3 options for this, 2 options for that, and 1 for that, and put them in order. There's 6 options total for that. So it's kind of neat. If the Q and U could be in either order, they just have to be beside each other. So let's do a different question where I have Matt, Mike, Tim, and Simon. Actually, that might be confusing. Matt, Mike, Tim, and Matt, Paul, Tim, and Simon. And Matt and Paul have to sit together. Okay. Well, and let's say I don't say Matt has to be on the left of Paul or whatever, and I'm going to sit them in order 1, 2, 3, 4. Well, this is the same question as this, except M and P could be MP or PM. So what you'll do is you have this thing 3 times 2 times 1, but you're going to multiply that by 2 to factor in that it could be MP or PM and multiply that up. Okay, so there are questions like that also. Okay, kind of confusing stuff, kind of neat stuff though, really interesting stuff. Send me an email if you're confused, and take care. Bye.